For billions of years, Earth has been a target in a cosmic shooting gallery. Asteroids, comets, and meteorites have collided with our planet countless times, sometimes small, harmless pebbles, sometimes extinction-level monsters. The scars are still visible across our world, from the deserts of Arizona to the depths of the Gulf of Mexico. But what if it happened again, not on land, but in the ocean? Over 70% of Earth's surface is covered by water. So statistically, the next big asteroid impact is far more likely to strike the sea than land. What would really happen if a massive asteroid, say, 1 kilometer wide, slammed into the ocean at tens of thousands of kilometers per hour? Would it cause a world-ending tsunami? Could it boil the oceans? Would life on Earth even survive? Let's dive into the science. The approach: when an asteroid enters Earth's atmosphere, it's traveling at incredible speeds, usually between 20 and 70 kilometers per second. At those speeds, the air in front of it compresses so violently that it heats up to thousands of degrees, turning the rock into a glowing fireball. Small asteroids burn up and disintegrate high above the ground. But a large one, 1 kilometer across or more, is too massive to break apart. It punches through the atmosphere almost intact. If such an asteroid were headed for the ocean, the first few seconds would be blinding. The friction and shockwave would ignite the air around it. Even before hitting the water, it would release energy equivalent to thousands of nuclear bombs. The moment of impact: now imagine it hitting the Pacific Ocean, the deepest body of water on Earth. The asteroid slams into the sea at more than 50,000 kilometers per hour. The water offers almost no resistance at those speeds. For a brief instant, the ocean behaves like solid rock. The asteroid vaporizes instantly. The surrounding water explodes outward, creating a blinding flash brighter than the sun. Temperatures at the point of impact soar to tens of thousands of degrees, hot enough to vaporize not just water, but the rock beneath the seafloor. Within seconds, a cavity dozens of kilometers wide and several kilometers deep opens in the ocean. The blast hurls billions of tons of water and steam into the atmosphere. The shockwave races through the ocean, through the crust, and through the air, circling the planet within hours. The tsunami: what follows is not a typical tsunami. Normal tsunamis, caused by earthquakes, displace the seabed and push long, rolling waves across the ocean. But an asteroid impact displaces both water and atmosphere violently. The initial wave near the impact zone could be over a kilometer high, a wall of water taller than any skyscraper. As it radiates outward, the wave grows wider but lower, spreading thousands of kilometers in every direction. By the time it reaches coastlines, the wave might be 50 to 100 meters high, enough to obliterate entire cities. No coastal defense could stop it. Islands and low-lying nations would vanish beneath the waves. The destruction would be global. The steam explosion: but water is not just displaced, it's vaporized. The intense heat turns millions of tons of seawater into steam, which rushes upward into the stratosphere, carrying salt, dust, and debris. This plume would rise higher than Mount Everest, forming a massive, mushroom-shaped cloud. It would darken the skies, block sunlight, and trigger violent weather across the globe. The sudden injection of water vapor and aerosols could alter the climate dramatically. Ironically, while the surface might first experience intense heat, the long-term effect could be freezing, a nuclear winter, caused by sunlight blocked by particles in the atmosphere. Earthquakes and firestorms: the shockwave from the impact would trigger powerful earthquakes and volcanic eruptions across the planet. Seismic energy would ripple through tectonic plates, potentially destabilizing regions thousands of kilometers away. Meanwhile, debris from the impact, molten rock, ash, and vaporized material, would fall back through the atmosphere, heating it again and causing global firestorms. Even areas far from the ocean could experience intense heat and fires, igniting forests and cities. In short, the entire planet would feel the blow. The scale of destruction: to understand the scale, let's compare. the asteroid that wiped out the dinosaurs 66 million years ago was about 10 kilometers wide. It struck near the Yucatan Peninsula, creating the Chicxulub crater and releasing energy equal to 10 billion Hiroshima bombs. A 1-kilometer asteroid would release less energy, but still enough to devastate civilization. The immediate death toll from coastal flooding alone would be in the hundreds of millions. The atmospheric and climatic effects could kill billions more through famine, collapse of ecosystems, and long-term environmental change. Could we survive it? Survival would depend on the size of the asteroid and where it struck. If the impact were in the middle of the Pacific, far from land, the direct tsunami damage might be reduced, but atmospheric effects would still be catastrophic. Governments could theoretically detect and evacuate some coastal regions if the asteroid were spotted in time. Modern telescopes can detect large near-Earth objects years in advance. But for many smaller asteroids, detection might come too late. Underground bunkers or remote shelters could protect small populations. Humanity might survive, but civilization would be changed forever. Long-term effects in the months following the impact, skies around the world would be shrouded in dust and steam. Sunlight would dim, global temperatures would plunge, and photosynthesis would slow or stop in many regions. Crops would fail. Oceans would acidify from dissolved gases. Eventually, after years, the dust would settle. The planet would begin to recover. Life would adapt, it always does, but the balance of ecosystems would be reset. New species might thrive in the aftermath, just as mammals rose after the extinction of the dinosaurs. Humanity, if it survived, would enter a new age, forced to rebuild in a colder, harsher world. Could it actually happen? So, how likely is this? Every year, Earth is hit by about 100 tons of cosmic dust, harmless particles that burn up in the atmosphere. Larger impacts are rare. Asteroids 1 kilometer wide strike Earth roughly once every 500,000 to 1 million years. NASA and other space agencies track thousands of near-Earth objects, NEOs. Most pose no immediate threat. However, there are still undiscovered asteroids out there. One day, one could be on a collision course. Could we stop it? If detected early, years or decades in advance, humanity might have a chance. Several methods are being studied: kinetic impactors, spacecraft that slam into an asteroid to nudge it off course, like NASA's DART mission in 2022. Gravity tractors, spacecraft that use gravity to subtly pull an asteroid off its path over time. Nuclear detonations, the last resort, detonating a bomb near the asteroid to vaporize part of it, creating thrust to push it away. These strategies could work, but only if we detect the threat early. A last-minute discovery would leave no time to react. What if it were smaller? Even smaller asteroids, 50 to 100 meters wide, can cause regional disasters. If one hit the ocean, it might not destroy civilization, but it could still send tsunamis across continents. The 2013 Chelyabinsk meteor, only 20 meters wide, injured over 1,500 people, and that was just from an airburst. A 100-meter rock could erase an entire coastline. Humanity doesn't need a dinosaur-killer to face catastrophe, just bad luck and bad timing. Lessons from history: the Chicxulub event wasn't the only impact in Earth's history. Craters on the Moon, Mars, and Earth tell us that cosmic collisions are a natural part of planetary evolution. In a sense, we owe our existence to them. Impacts delivered water and organic molecules to the early Earth, setting the stage for life itself. So the same forces that can destroy life also helped create it. It's a humbling reminder that we live on a fragile planet in a violent universe. Humanity's future among the stars, maybe the best defense is not deflecting asteroids, but expanding beyond Earth. Building colonies on the Moon, Mars, or orbital habitats could ensure that no single impact could end humanity forever. As long as we remain confined to one planet, we are vulnerable. The cosmos doesn't care how advanced we are. One rock in the wrong place at the wrong time could reset everything. But knowledge is power. The more we understand, the better we can prepare. Final thought: so what if an asteroid hit the ocean? The result would be devastating: tsunamis, firestorms, freezing skies, and mass extinction. But it would not be the end of the world forever. Earth has endured impacts before. Life has recovered each time, stronger and more adaptable. Humanity, too, could rise from the ashes, wiser, more cautious, and perhaps finally aware of our place in the universe. Because every time we look up at the night sky, we're reminded of a simple truth: space is beautiful, but it's also dangerous. And it's up to us to be ready. Subscribe to Why and How, and let's keep exploring the science of the impossible.